In this video, let's talk about this brilliant math problem that originated from China. We have a parallelogram that was cut multiple times in a weird and random way. All the yellow areas are shown. What is the area of the red region? Not gonna lie, but when I saw this problem the first time, I thought the solution is gonna be complicated. I was stunned for a bit until I realized you can actually solve this in 60 seconds, maybe even faster. I'm going to tell you how, but you gotta know some area properties first. Don't rush to the solution as it was the easy part. Understanding the concept is way more important. A parallelogram is a quadrilateral with two pairs of parallel sides. The area of a parallelogram with base length b and height h is simply base times height, or BH. The area formula is the same even for different orientations. As an example, say you want to rotate the parallelogram like this, then this is the base side, and this is the height. The area formula is still the same, base times height. How about the area of triangles inscribed inside a parallelogram? If the triangle's base and height are the same with the parallelogram, then its area is 1/2 times base times height. The area can also be written as 1/2 times the area of the parallelogram. Moreover, as we move the apex of the triangle, the area remains the same as the base and height stays the same. What if the triangle is horizontal? Well, let's try to rotate to visualize better. This is the base, and this is the height. The area of the triangle is still equal to 1/2 times base times height, or 1/2 times the parallelogram's area. The point here is that when the triangle has the same base and height as the parallelogram, its area is half of the parallelogram. What if we have two triangles where their bases span along the base of the parallelogram? Say the base lengths are B1 and B2. The combined area of the triangles is 1/2 times B1 plus B2 times height, but B1 plus B2 is equal to the base of the parallelogram. That makes the combined area equal to 1/2 times base times height. Once again, this is half the area of the parallelogram. So another conclusion is that no matter how many your triangles are, as long as their bases span the entire base of the parallelogram, their combined areas is always half the area of the parallelogram. Let's get back to our problem. Let the empty areas be E and G. Let X be the required missing area. This shaded triangle has the base length and height that of the parallelogram. From our earlier discussion, this triangle must have an area that is half the parallelogram's area. But referring to the figure, the area is the sum E plus 79 plus G plus 10. How about the combined area of these triangles? The base of the triangles spans along the base of the parallelogram, so their combined area must be half of the parallelogram as well. But upon using the given figure, the combined area is X plus E plus 72 plus G plus 8. Since we have already established that both of these areas are half the area of the parallelogram, then they must be equal in areas themselves. All we have to do is substitute the area expressions obtained from the previous step. Cancel out the variables E and G from both sides. The only remaining variable is X, so isolate. The equation becomes X equals 79 plus 10 minus 72 minus 8. The value of X is 9. Therefore, the area of the red region is 9 square units. That's it. It is so easy to calculate when you are familiar with the concept. You can definitely do it within a minute.